Do you know how to build an atomic transaction system? Well, I'm Piyush Mishra and this is Build PKG, and today I'll be explaining how to build an atomic transaction system. So these are the topics which we will be discussing today, and from starting from what is an atomic transaction, then going through the clean architecture and idempotency, webhook, and rate limiting. So this is a simple transaction system which I did build, and if you are interested in code base, then here it is for you. You can just go up and check it. It's written in Rust and it's very simple, like very easy to go through. It is using a clean architecture, so if you are familiar with it, then it won't be a big issue for you to just go through and have a look what it is. So first of all, let's understand what is an atomic transaction. In simpler words, a transaction is an operation, like an operation. So what about the operation? Like why we are calling it atomic, like atomic. So when we say something is atomic, we mean that it is not breakable. It is the like smallest unit of something. That's it. So an operation can be compromised on multiple steps. Step 1, step 2, step 3, step 4, for example, up here. So when a transaction or an operation is atomic, if a step fails, for example, step 2 is failing, then the whole system will be rolled back to the state where we started, and there won't be any effect on the main system, and the whole output of this would be a fail. If everything goes through and everything passes, then the whole change would be committed, or whole change would be affecting the main system, and it will be a good success. So that's atomic transaction. Now there could be, like, if you want to understand it in a much easier way, you can think of it like something as, we have a master branch in Git, and from master branch what you can do is, like, this is a master branch. From master branch what you can do is you can have a feature branch, and this feature branch can have its own changes. You just made a feature branch, and this made you did some kind of changes, some commits, and with those commits, at the end of the day you will be merging it, isn't it? So when you merge it, the changes would be done. Until and unless you merge it, there is no changes in this main branch. And if there is some problem in this feature, like if you fail to implement this feature, you are not gonna merge this branch, and everything is safe, the whole system is safe. So that's how atomic transaction works. You either it gonna pass or it gonna fail. That's the whole two part of it. Now, to implement this in a system, it requires something like a little complicated things, like two-phase commit system. You can do something like this two-phase commit protocol, where you have two participants and there is a coordinated way of writing, so uh, the system could be rolled back. Though it is a good solution, but it is a little complicated to implement. So what we went with was using the transaction provided by PostgreSQL. Yeah, you may be a little bit confused, like why should we go for the Postgres transaction? Like suppose we are only using Postgres, and we our all operations are being done only in Postgres, then there is no issue. You get me? There is no issue. Like we can start a transaction, go for the whole thing and commit it. If something fails, we can always wish to not commit it, which will eventually just roll back the whole system. It's like not gonna affect the main branch. So that's the whole thing. And it's how we are implementing it. But suppose you have multiple database, MongoDB is there and there is the PostgreSQL. You are just trying to cope up with both of them, then having a transaction of PostgreSQL won't promise you to have it with MongoDB. What I mean is, suppose what you did is you started a transaction for PostgreSQL and MongoDB. Okay, you did your changes and now you are committing. The committing won't be just one page thing. There will be commit for PG and commit for MongoDB. Okay, that's fine. That's fine if there is commit for PG and there is commit for MongoDB. But suppose if commit for PG fails, that's okay. But suppose if MongoDB commit for MongoDB it fails, then the commit like the changes is already done in the PostgreSQL, and now you don't have a way to just roll it back. In this kind of situation, you need to think about it, like how to find some other solution, like go for some two-phase commit or something like that. But for our situation, for the sake of simplicity, I've used just the PostgreSQL, so we are not bound to use the transaction with in this way. Though in future, if I just expand it, I might need to use things like that, and it's okay. So I'll just show it up here how the transaction is going on. So to implement it, what I have done is I did make a middleware. Like if you are a little bit familiar with web framework, there is something called as middleware, which executes before and after the whole response is formed. Like before and after handler function, you can just think like that. So there is this injector. It will inject the transaction. It will inject the transaction, and it will just wait for everything to go on. The whole cycle will go and come back, and when it comes back, it will just commit it. Simple. Commit it. That's what the whole transaction thing is implemented. I can just show you in the code if you are a little bit, though there might be some kind of issue with this code because I did it for first time. But if you know, if you get to see some problem, please put it in the comment so I can just see and understand, okay, this is the thing which I can improve. For now, there is this transaction. There is a DB store. DB store is abstract interface, is an interface which does have a start transaction function. It can start a transaction. Then we put everything in a request data. Request data is a data which will be available for a request, like throughout the request, and it is unique for a request. Okay, so we put it into a request data. Then these two lines just execute the whole thing, and at the end of the day we just commit the whole transaction, and that's it. That's how the thing is implemented. Rest on, you can just go up and look into how the things are working. Now let's talk about, since we are done with this atomic transaction, let's talk about the clean architecture. It is something very interesting. Since we are looking at the system design, now we should like see how the things are being built, how you can make a scalable system which is like a future proof system. And though we cannot guarantee to have the best system or the most efficient system, but yeah, we can have a guarantee that most of the part of the system is changeable. Let me tell you how. The clean architecture says that your whole software will be divided into layers. For example, up here we have 4 layers. Okay, It is like advancement of something called as layered architecture, but yeah, just check for it. So the outer layer is for IO, input and output. What kind of IO? The IO could be a UI. You know, UI, there's input button and stuff. So the IO could be UI, there could be framework, there could be devices, there could be DB. You might ask, Piyush, what about the DB? How can a DB be a output device? Isn't that like really not making sense? Well, let me tell you something. Suppose you have a software. Okay. Now this software need to interact with DB. Cool. And can you see what you can do with this DB? You can read data from it. You can write data to it. You can query data from it, which is a reading of it. And you can just write in very fashionable way. So it's an input output device. Look at it. It's just a separate system. Like whenever, in simple words, whenever you are interacting with some other system, it's a IO. You have to do an input output with it. You don't have any other way of interacting with another system. You just have to do an input and output. So whatever goes for the outer boundary, it is the input output system. Second is the controller. Controller is a pathway to use case. Well, just put it into the mind. There is a path which you need to find. For example, it is, you can just think it as a router. It can route the thing to the particular function which have actual business logic. And use case, as we came to the word business logic, really it just mean the business logic. For example, you can think of it like in a login system. In a login system, you have things like login button, and then you're gonna click it. When you're gonna click it, the login will happen. What is login? Login is a use case. Or there is a forgot password button. So there is some operation for forgetting password, like you forgot the password, you want to reset it. So resetting password is a use case. Sign up is a use case. Those kind of thing. For example, even in the real world, you have a hammer. Okay, you have a hammer. You just have a hammer, big hammer, and for that there could be multiple use cases of this hammer. You can nail, you can put a nail, you can just break things, you can crack a shell, like lots of things. Those all things are its use case. How you gonna use it? That's the thing. So this is the business logic where the business logic gonna sit, and at the end of the day, like very end of it, they are the entities. Entities are representation of real world object or any kind of abstract objects. For example, an account, a hammer, a car. Those things are entities. So that's how the things are laid. And one beautiful thing the clean architecture says is that whenever, can I just delete this? Yeah. The one of the beautiful thing the clean architecture says is that whenever you want to interact with the system, the data have to flow from outside to inside. Simple as that. There cannot be a straightforward data moving from inside to outside. This is bad because if you directly use something like DB inside the entity, now these both are coupled. Entity now depends completely on DB class or DB stuff. And whenever you want to change the DB, you have lots of changes in entity. To avoid this, what we will do is we will use something called as an interface. And we will, instead of talking directly to the DB, we will talk to the interface, and this interface will talk to the DB. It's like a contract that our interface will define what are the function, what are the features the DB should look like. The DB should look like. If the DB have those functions, then great, we can use the DB as put it in here, like just put it in here, like think of it as a, it is actually like I can say there's a very popular design pattern called as dependency injection. So if you are a little bit interested in this, can I get a good picture. Well, this one is a little complicated. Anyways, well, it just says is that whatever you want to take it as an interface, take it as a contract, and yeah, I did draw something up here which I can show just to share how the things are played off. Suppose we have a login controller. Actually, it's yeah, it's a login. No, not it's not a login controller exactly. It's not a controller. It's part of use case. Yeah, suppose you have a login use case and you want to do some kind of login operation on database. Okay, there should be a function for login. Now, whenever this use case have to talk, it will talk to this login function. It will give it some argument and take some output. Well, this login function is representation of any kind of login function which have this signature means which looks like it. Okay, to do this we're gonna implement this interface on any kind of class. For example, mysql class. Now this login operation will use mysql. For mongodb class, now this login operation will use mongodb class. Anytime we can use this or this depending upon what we feed it in the use case, like what we say the use case to use. Okay, it will make it like independent, like very much independent of what kind of system we are using. That's the beauty of clean architecture. If I want to show you it in this part, look at this. There is the controller. We just talk about the controller right now. And leave this part. This is actually where we're gonna start it. Actually, these both are part the kind of same thing. These are like kind of part of controller itself. Although I just mentioned it as a controller. But actually this is a little complicated for now because I did add a function to start the server which actually starts the actor2, which is not actually part of it. That's why I didn't show it as a dotted line. For now, just understand this is a controller. Okay, and this is use case. Okay, these are the interfaces which gonna help it talk to the external system. Okay, these are the concrete implementation of those interfaces. Okay, everything good, everything good. And this whatever rest is part of whatever you can think of. Understand is that now code is not dependent on these two. Simple. Code is not dependent on webhook actor or SQL XDB implementation. Why it is not dependent? Because it is using interfaces, and these interfaces won't be changing like rapidly. Getting me? We can change this, we can change this, we can have something like other thing like MongoDB or any DB. Even for the actors management system like webhook actor, if you are a little bit familiar, otherwise we'll be talking about it later. For now, for the webhook actor manager system, it's like we can use Kafka or something else. So that's how the whole thing is going on. Now, since we have talked about did talk about the clean architecture, it's good. Let's talk about the idempotency. Up here, idempotency says that if I did an operation, if I did a transaction, and I do it again, it shouldn't make changes again. Instead, it should give the success response with whatever response we got this time. You can show it a fail also, but most of the people do it as instead of showing a fail, they will give the same response. How does it work? There should be some idempotency key, and idempotency key should represent the request because HTTP is a sessionless transfer. Like there is no session going on between HTTP requests. So it's you need to make your own session, and the session should have some session ID, which is idempotency key. You can take the idempotency key in any way. For me, I did take it in the headers. I will show it, and up here in this diagram, there's this middleware which is doing the idempotency thing. I will show you how. Up here in the middleware, there is the middleware, there is this service, and here is the middleware thing going on. If you are a little bit familiar with the Actix framework, again, you can just have some idea what is going on up here, though this might look a little bit complicated to new people, but just try to understand it. Don't bother about what is this. It is just we are extracting DB transaction. If no, we just respond that the DB transaction is not working. Then there is this DB transaction. We are extracting the idempotency key from the header. Simple. Then we have this idempotency item, which is actually we are extracting the idempotency item from the database. You can see tx.get idempotency item. If there is the response already stored, we're gonna give the response. Otherwise, after the whole response has been made, we will store it into the database. Set idempotency item. That's it. Simple. There is nothing complicated. Well, that sums up, really, that sums up. Like, did you think how easy it was to implement this thing? Now, since we have talked about this, we need to talk about the webhook. Up here, let's come back. What is a webhook? It is an event-driven system. What it means, there is some event going on, then that event will trigger something. Okay. Suppose a transaction happened. Bank A given to A gives money to B. That's a transaction. That's an event. That's something. Now what it will go is this event will trigger the web distributor. Now what will happen? Not just the web distributor. What it will do is it will have a queue. Okay, everything good. And in this queue, it will add a message. That particular thing has happened. And it will poll the web distributor. The web distributor will check the queue. Okay. And it will iterate over all the users not the users, but all the webhook servers which are actually listed, and it will send it. Simple as that. Now what are the components required? There is a requirement for queue, there is a requirement for a poll function, and believe me or not, up here again we did talk about the interface. See, up here in the interface it's a tray, and there are two functions required for it: queue the webhook, poll it. Simple. And there is this concrete implementation which have a actor and which have a webhook manager. What does this thing does it will use the DB. We are using PostgreSQL as a queue, though it is not efficient, but it works. Simple as that. So we're gonna just queue the whole message, and there is this poll function which uses broker. And why we are using broker, I'll tell you. So Actix is a framework for actor. Let me show you. Yeah. So Actix is a framework for actors. What is an actor? Actor is a entity. Actor is an entity. Yeah. Yeah. So actor is an entity. What it does is it waits for some kind of message through any broker, and then it will process the message using its handler, and then it will give some kind of response if needed. Okay, this is the handler. Okay, simple as that. Up here also we have registered a broker, subscribed it. If you are a little bit familiar with event queues and things, you can think of it as an event queue. It's like a queue in which messages would be stored in memory and it will be delivered to all the subscribers. So, and we did say where we are sending it, it was in the poll. Up here, it's in the poll. Okay. So from here we are sending the message. and this is where we subscribe it. And this have this poll where, yeah, after webhook message it have poll. There is this handler function, and what it does is it gonna just generate a request with the whatever message came, and you request. I don't know why did they name it as REQWEST. Request. Okay, it's gonna use the request client and make the whole thing like transaction and show the error message over everything. That's it. That's it. How the webhook is working. Simple as that. Might have got a little bit of idea about it. Cool. Come to this rate limiting. Okay. This is a little tricky part where I actually got stuck for some time because I don't know. What I did at first was the first solution which I came up, which I did change for now, was that I did divide the time into 60 seconds. That's 1 minute. Whenever the first request hits, I will start counting to 60 seconds and I will count number of requests coming. Okay. So we have count, we have a timestamp, and we can now calculate the whole thing, how many count is there and how many timestamps are there. And if the number of count exceeds 100, I will share that, man, you have done already lots of requests. For now, just wait a minute and do it later. This is a good solution. This is a good solution. Not an issue. But I got to a problem. I did discuss it with someone and I got to a problem. Suppose someone makes one request of me, and then at 55th second he got mad and started making lots of requests and made like 90 requests. Then later on at 60 to 65 seconds in between this, he got up and made tons of requests again and made like 90 requests. Good, not an issue. This sums up to be 180. That's a problem. In 10 seconds, he was able to make 180 requests. What was our goal? To keep it less than 100. That's a violation. What shall we do? What shall we do? I got to a new solution. With this, I got to a new solution. The new solution says that instead of doing it this way, like checking after the first request, instead of checking how many requests came after the first request, what I will do, I will mark the current request. This is the current request, and calculate the last 60 seconds. Okay, and see how many requests have been done. If the number of requests is more than 100, then I will block it. Simple as that. How is it effective? Suppose if the guy makes this 90 requests, not an issue. We are up here. We are up here. We are up like here already. No, we should be in middle of this. Somewhere this. Okay. If he makes 90 requests, acceptable, not an issue. Then he makes next 10 requests, still acceptable, not an issue. Once he makes 101th request, this is 101th request, then it triggers. Easy. Then it triggers, not an issue. This will just prevent the whole mess of requests, and it will prevent me from getting above 100. And just think about it again. Just think about it. Can I make it format? Why do you have background? Don't have backgrounds. Set it as default. Yeah. So suppose this is the frame now. This is the frame now. Okay. Like there should be a bigger frame. Suppose that Yeah, suppose we have it like, instead of doing this way, he did it like lots of requests starting from here only. Okay, suppose up here he made the 100. Okay, and he's unable to make the request. He can wait for a second and then he can make one request only. He can make wait for another second and he can now request only one request. He can wait for like few more seconds, like 5 6 seconds, and then few of the requests are lost up here, and he can make more requests like that. Isn't that cool? Isn't that cool? I'll show you the implementation, how it is implemented, and then I'll show you if something interesting I have, which I think I should show you. Did I? Yeah, I placed something weird here. Well, check it. Check this thing. Check this booklet. There is this counter. There is this hash map. There is our API key. There is our API key, and there is our instant of timestamps. Why timestamps, Piyush? So how we will keep track of when did this request happen? There is the timestamp. And for every request, we're gonna add the timestamp. Then we're gonna count how many requests in this from current request in last 60 seconds. Simple. Now up here, there is the API key. We get the API key. Now, how we do it? We use credential and thing and extract it. Easy, not an issue. Then we get the API counter. That's the counter for API key. For particular API key, simple hash map operation. Then we get the timestamp of visits, like for that API key we get the timestamp of visit, like that API key. Then we have the current time instant. Why did we take it right now instead of taking a lot many time? So we have a marker. We don't want to have multiple requests. For example, this is the particular time when the request actually started, but suppose it took like 100 millisecond, though that's a lot, but 100 millisecond, in 100 millisecond there will be lots of different timestamps, isn't it? Just a millisecond passed in the timestamp chain. So we don't want that thing to happen. That's why we take it up here. Now what we do is we take the count. Okay, everything is good. We lock it. Easy. Lock it, read, write, lock, not an issue. There is retain mute. If you're not familiar, it can remove the items which doesn't match this condition. Which condition? That is the current, that is like beyond last 60 seconds. I will remove everything, and then easy. If I did remove those, I can check for the maximum request count and things. Why do this? Is it very expensive? No, it is not expensive. Max to max there would be 100%. Yeah. The size of that thing cannot be bigger than 100. If it is bigger than 100, then it will go in this. Sorry, if it is bigger than 100, then it will go in this. If it is bigger than greater than 100, then it will go in this part, and there is no way we are adding it in the timestamp. Otherwise we will add the thing into the timestamp, and if there is nothing, like there is no request, then we'll drop it. That's it. Simple as that. Very easy. You can implement it. So that's how we complete the whole topic available in this. And it completes the whole topic. There is one more thing I would like to discuss about for now. This is actually this TV. I just want to show you. We did talk about the transaction. So up here it is an interface, and we can say that we did make multiple interfaces for different kind of operations, and we are implementing it for SQLX. So that's the thing. That's how the thing is working. And up here in router, which I said that this is start function, I did put it at a wrong place. Later when I was like finished with the whole thing, I realized that I kept it at a wrong place, because at the end of the day I kept it outside in this lib.rs, and I thought, why not I did it before only? Why should I wait for this? But that's how I did it, and now I don't want to move it anywhere because it's in my head. Few of the things stays in the head, and some of the things make sense while you're working. But you should write a good code, and I did try to make most of the things very good. For example, how we are passing the concrete values. Check this db store. This db store is actually a dynamic db store, which is like polymorphism being done, and we have a concrete value which we are like initiating this SQLX DB store, and we are parsing it, like casting it. We are casting it to the arc DB store and making it like polymorphic, and change the data type and just put it inside up here. Even for the webhook, we have done the same thing. And with the controller, since we can extract this request data and or something like that, like request data, or did I, yeah, in webhook maybe. No, most of the places have done this. Just the request data. Did yeah, in here I did, in webhook one I did extract the webhook data. Anyways, so just try to understand. Yeah, just try to understand in the request data itself up here. This is DB transaction, which is actually, you can see, which is using polymorphism up here. So that's how the things are, and that's how the things could be. Like even inside this function also, we are using the same, the dbref transaction, which is just a easy way of saying that it's a dynamic dispatch, if you are a little bit thinking about this. Well, that's how the thing is. We got into the core. This has some kind of business logic. When we are assaying the business logic, we don't mean how we gonna interact with the database. The business logic is simple. There is an account. We want to get the account. We want to check it is like something like okay or not, or something like that. Even for transaction, we have this credit to account. We don't want to know how to credit to account, like how the database is handling it. But that's the business logic. We want to create and get that ID and make it the things like that. We want to send it to webhook manager too, so we have it here. So that's how the thing is done, and it's good. Anyways, that's all. We finished everything, and have a good day. Thank you.